Welcome to Grab and Go Info. MLflow is an open-source platform for machine learning lifecycle management. MLflow on Databricks offers an integrated experience for running, tracking, and serving machine learning models. In this tutorial, we will cover how to use MLflow to track different model versions, how to retrieve MLflow experiment information programmatically, how to retrieve MLflow information using Databricks UI. Let's get started. In Step 1, we will import the libraries. Pandas, NumPy, and PySpark SQL functions are for data processing. Matplotlib is for visualization. Make Regression is for creating synthetic modeling datasets. From the PySpark.ml library, we imported Vector Assembler for feature formatting, Linear Regression for model training, Regression Evaluator for model evaluation, and Pipeline for pipeline creation and loading. We also imported MLflow, MLflow.Spark for the Spark flavor, and MLflow client to query model information. If you are using the Databricks runtime for machine learning, MLflow is installed. Otherwise, MLflow package can be installed from PyPI. In Step 2, we will create a synthetic dataset for the linear regression model. Using Make Regression, a dataset with 1 million records is created. The dataset has two features, and both of them are informative. It has a noise of 10 and a bias of 2. Random state ensures the randomly created dataset is reproducible. The random state does not have to be 42. It can be any number. After the dataset is created, we can scale the values to the desired ranges. In this example, the first feature is scaled to values between 1 and 100, the second feature is scaled to values 1,000 and 5,000, and the target is scaled to values between 3,000 and 80,000. The output of Make Regression is in array format. We convert it into a Pandas data frame. Then the Pandas data frame is converted into a Spark data frame. Summary gives us the summary statistics of the dataset. Next, let's check the scatterplot between the features and the dependent variable. The visualization was created using the Databricks notebook built-in functionality. To learn more about it, please check out my previous tutorial on Databricks dashboard for big data. We can see that both features' scatterplots show positive trends, but their shape and slope are different. After creating the modeling dataset, in Step 3, we will make the train test split. Using random split, we split the dataset into 80% training and 20% validation. Seed equals 42 makes the random split results reproducible. However, we need to make sure that the same cluster and partition number are used when reproducing the split. We got 800,299 in the training dataset and 199,701 in the testing dataset after the split. In Step 4, we will create the first model using linear regression. In this model, the features and the dependent variable created in the synthetic dataset will be used directly. So let's give it the run name of LR raw data. Firstly, a linear regression model is trained using Spark ML. To learn more details, please check out my previous tutorial on Databricks linear regression with Spark ML. Then the parameter of the model is logged. For this experiment, we plan to create two versions of the model, one with the raw dependent variable, the other with the logarithm of the dependent variable. Model 1 uses the raw dependent variable. To log this information, we save the name of the dependent variable into a parameter called target variable. We also logged the parameter for elastic net. 0.5 means 50% of lasso regularization and 50% of ridge regularization. To learn more about regularization, please check out my previous tutorial on lasso versus ridge versus elastic net regularization. After that, we logged the model for this run, made predictions on the testing dataset, and saved the prediction CSV file as an artifact. When doing model performance evaluation, we calculated RMSE, R-square, MSE, and ME, and they are logged as the experiment metrics. Finally, A plot for the dependent variable distribution is created and logged as an artifact. If you find the information helpful so far, please click the like button and subscribe to the channel. In step 5, we will create another model. Taking logarithm is a commonly used technique for data transformation. It is usually used to transform non-normal distributed data to a normal distribution. Our synthetic data is already normally distributed, so it does not need the logarithm. But we would like to create a model version with log transformation for illustration purposes. Firstly, we name the run_lr log target, indicating that the target variable is the logarithm transformation of the raw data. Then the logarithm of the dependent variable is created for both the training dataset and the testing dataset. The rest of the code is very similar to the previous model, except for 3 changes. The first change is the information related to the dependent variable is updated to the logarithm version. The second change is that the elastic net param is changed from 0.5 to 0.8. The third change is related to the model prediction, because the target label for the model training is in logarithm form. The predicted values are in logarithm too. So we need to take the exponential of the predictions before doing model performance evaluation. In step 6, we will get model experiments information programmatically. List experiments from MLflow client lists all the experiments and their IDs. There are 2 types of experiments: workspace experiments and notebook experiments. Workspace experiments are created from the Databricks Machine Learning UI or the MLflow API. Any notebook can log runs to a workspace experiment by experiment ID or experiment name. We can access a workspace experiment from the workspace menu. Notebook experiments are associated with specific notebooks. The experiment is automatically created by Databricks. We can access a notebook experiment from the notebook. The experiment in this tutorial is a notebook experiment. To get all the runs for an experiment, use MLflow, search runs and pass in the experiment ID. We can see that the model with the raw data has better performance than the log version of the data. When there are a lot of runs in an experiment, we may want to sort the runs in descending time order and get the information for the latest runs. Max results controls the number of runs to keep. In step 7, we will talk about how to use Databricks UI to retrieve the experiment information. Step 7.1 is about accessing the experiment information within the notebook. To access the experiment information within the notebook, we can click the experiment icon on the upper right of the notebook. The 2 versions of the models are shown on the right sidebar of the notebook. Step 7.2 talks about how to access the experiment UI. To open the full experiment UI on a new page, click the blue experiment UI at the bottom of the sidebar. Step 7.3 is about accessing the experiment run information. To check the details of a run, click either the blue start time or the blue spark under models for the run. We can get detailed information about this run by clicking the list of options on the left-hand side of the UI. It also provides the code for prediction using Spark and Pandas data frame. In this tutorial, we talked about how to use MLflow to track the Spark ML linear regression models. We covered how to use MLflow to track different model versions, how to retrieve MLflow experiment information programmatically, how to retrieve MLflow information using Databricks UI. If you found the information in this tutorial helpful, please click the like button and subscribe to the channel. I publish tutorials on machine learning, deep learning, and big data processing every week. If you prefer the written version of the tutorial, please go to grabandgoinfo.com. I will put the link in the video description. This is the blog post for this tutorial. It has all the code and explanations in the video. Thank you for watching. See you in the next video.